Hello, my name is Anshul Gandhi and welcome to my presentation on the Personal Expense Tracker, a mobile application designed to simplify personal finance management. This project is developed for the module Emerging Mobile Applications, and today I'll walk you through its design, key features and the testing outcomes. Let's dive into the system overview. This personal expense tracker is an Android app built with Java designed to help users monitor spending habits through expense logging, categorization, and visualization. Key features include user authentication, geolocation tagging, dynamic charts, SQLite database, light and dark themes. The app follows MVC model view controller pattern, which is an architectural pattern separating data logic, UI, and backend operations. This improves scalability, for example, if we later integrate a cloud storage. Now let's explore the app's functionality through its use case diagram. Here the user interacts with all core features: authentication for secure access, expense management adding new records and reviewing past spendings, data visualization through dynamic charts for trend analysis, utility features like geolocation tagging and theme customization. Now in this slide we have the class diagram. This class diagram reflects our MVC architecture and key components. First we have the model layer. The expense class encapsulates all data fields: amount, category, date and optional location. Expense database helper handles database operations using SQLite, ensuring data persistence. Next we have the view layer. Main activity, expense activity and chart activity manage the UI. For example, input forms, charts. For example, chart activity collaborates with expense chart manager to render visuals. Then we have the control or the logic layer. Expense chart manager uses MP Android chart to transform raw data into pie or bar charts. The user class handles authentication logic separates from expense operations. Usage of design patterns. Our app's architecture relies on four key design patterns to ensure efficiency, maintainability, and scalability. First, the singleton pattern in our app database class guarantees a single thread-safe database instance across the app. By using synchronized initialization and destructive migration fallbacks, we prevent data corruption and ensure consistent access, which is critical for financial data integrity. Repository pattern. The database feeds into the repository pattern, which acts as a centralized data abstraction layer. The expense repository decouples our view model from direct SQLite access and handling all data operations, whether local or future cloud based, through clean API. This single source of truth approach simplifies offline support and makes the future upgrades seamless. Now we have the observer pattern. To keep the UI reactive, we implement the observer pattern via live data. In expense fragment, the observe method automatically updates the recycler view when new expenses are added, thanks to lifecycle aware subscriptions. This eliminates manual refreshes and prevents memory leaks, creating smooth user experience. Next, we have the DAO pattern. Underpinning this layers is the DAO pattern, where interfaces like expense DAO abstract SQL queries. Compile time verification of query statement catches errors early, while annotations like insert standardize conflict resolution. By isolating database operations this way, we ensure maintainable type safe data access through the app's lifecycle. Now let's walk through the sequence diagram. When a user adds a new expense, this diagram perfectly illustrates our clean architecture in action. It all begins when the user enters expense details in the add expense fragment. Instead of directly touching the database, the fragment delegates this request to the expense view model, maintaining strict UI database separation. The view model then routes the data through the expense repository, our single source of truth, which involves the expense DAO's insert operation. Here's room magic kicks in. It automatically handles background threading to execute the SQLite insert, ensuring the main thread isn't blocked. Once persistence succeeds, the DAO updates its live data stream, triggering a cascade, the repository. Then the view model and finally the fragment receive the update without manual pooling. The UI reacts by showing a confirmation completing the loop. Notice how each layer has single responsibility. fragments manage UI, view models handle logic, repository coordinates data, and DAO deals purely with SQL. This is not only making the flow of thread safe but also simplifies testing and future scalability. For example, swapping SQLite for Firebase would only require repository level changes. User interface diagram. Our interface delivers financial clarity through six purpose-built screens. First is a streamlined login and register page with instant validation. Second is dashboard with spending snapshots and quick actions. Third, expense form featuring smart inputs like date pickers and category dropdowns. Fourth, filterable expense list with visual category markers. Fifth, interactive charts with MP Android chart for spending trends. And sixth, settings including our dark mode toggle. We prioritize consistency with adaptive color schemes and iconography and real-time updates across all screens. Every interaction from swipe to delete gestures to one-tap chart adjustments was designed to make expense tracking effortless and maintaining robust functionality. Test plan and unit testing. To ensure reliability, we implemented a rigorous testing strategy covering all critical workflows. Our test plan validates 7 core scenarios from user registration and login to expense management and theme switching. Each test case follows the pattern, action, expected result, and actual output as shown in the subsequent slides. For registration, we verify successful account creation with valid credentials and proper error handling for duplicates. Login testing confirms authentication works while preventing unauthorized access. These are the expense management tests demonstrated successful by saving of complete expense records, input validation blocking incomplete submissions, accurate historical data retrieval across categories. Visualization test validate chart generation from live data, while theme testing confirms instant UI adaptation. We did a manual testing with my own personal device, which was Samsung A50, which has Android 11. We also used the dark and light mode switching. SQLite data persistently worked well between the sessions. Now I will be showcasing you my live demo project. Let's begin. Come to the live demo project of the personal expense tracker. This is the Android Studio, and here are our some files that we have created. This is the main activity file which we have created. This is the login activity file. This is the activity main file. Here is the our bottom menu, and I'll be showcasing you the build Gradle file. So here is our build Gradle project level file. This is the application level file, and these are the dependencies which we are using. This is for Android charts that we are going to use, and we are also using the map services for the location and the date time picker. This is my manifest file, and I have connected my own device. I'm not using the emulators. Let us now switch to the mobile phone. Here is our app. Let's first try login with credentials. It will show a validation error message. Now trying with unregistered user details again shows a validation error message. Let's register the user now. Now the user is successfully registered. Let's log in. We are now logged in. Here is our home page. Let's try saving expense without adding any details. It will show a validation message. Now let's add details for the expense. In the given get location button, we have used Google Maps API. Once we give permission and click the button, it will fetch the current user's location. Now let's add more details. Now we have saved the expenses. Here are the list of expenses we have saved. This is the analytics section showing the pie chart and bar graph. This is the dashboard page. Now let's test the dark mode toggle button. This is how the app looks in dark mode. Let's log out and log in with other users' credentials. Here are the expenses of the user. Now if you might have noticed that if the user turns off the dark mode toggle, it will be off when we log in with other users' credentials. Now logging in with other user. If we try to save expense without adding price, it will show validation message. It will allow us to only save if we put all the expense details except the location. Here the live project demo ends. Thank you for watching. In conclusion, our personal expense tracker successfully delivered on its core mission, empowering users to monitor spending through its intuitive login, categorization, and visualization. The development leveraged Android's robust ecosystem SQLite for reliable local storage, MP Android chart for actionable insights, and MVC architecture for maintainable code. Three strengths stood out: our modular design simplified debugging and future updates, chart integration transformed raw data into understandable trends, and SQLite provided consistent offline performance. However, the journey wasn't without challenges. Real-time chart refreshes required careful live data, while responsive layouts demanded extensive device testing. We also implemented rigorous input validation, rejecting malperformed dates and empty fields to ensure data integrity. Looking ahead, three improvements would elevate the app further: cloud sync for cross-device access, budget alerts to prevent overspending, and expanded testing with frameworks like Espresso. These refinements would build on our solid foundation while addressing real user needs. Here we end our presentation. Thank you for watching.